So we're going to look at areas above and below the x-axis because we need to kind of treat them differently. So when we take a look at the velocity function, if we have the velocity function, in this case here, part of it is above the x-axis, part of it's below. When the velocity is below the x-axis or negative y values, what does that mean for the velocity? Well, for the velocity, that means it's going backwards. Okay, so the negative velocity means backwards, or we're losing our displacement. Okay, so that negative velocity is going to work against our displacement. So this question here, we have part of it we're going moving forward, part of it's moving backwards, so that the velocity function is that parabola. And using 5 intervals, we're going to calculate the net displacement. Okay, so my first sentence says here, use a left hand. Okay, so I'm going to use the left hand. So I'm going to start at 5. I'm going to make my width equal to 1. Okay, so that's going to give me an area of 5 meters. Okay, the next one here looks like a height of 4. And so that's going to give me a 4 meters of displacement. Here we'll say it's 2.5. So it's going to give me 2.5 meters of displacement. Okay, my left edge is at 0. So this one here, although we know it's moved, that one really is just going to give me a displacement of 0. And then for the last one, we're going to have our height here looks like it's going to be about negative 3.5. Okay, so that displacement is going to be negative 3.5 meters. Okay, so when we talk about displacement, we need to count the negative going backwards against the positive going forwards. So when we talk about the net displacement, okay, or the change in D, that's going to be equal to plus 5, plus 4, plus 2.5, and then minus 3.5. And so our net displacement works out to be positive 8 meters. So we've moved forward 8 meters based on the areas that we've calculated. Now, this is different than distance. Okay, so our distance traveled is equal to the absolute value of displacement. So that means it's going to be 5 plus 4 plus 2.5. But instead of minus 3.5, we're going to add that as distance traveled as 3.5 units of distance traveled. In that case, we're going to end up with, it looks like, 15 meters of distance. Okay, now this is different than displacement. So this question was asking for displacement, not distance. So there is our net displacement.